My future is a future where technology is married to compassion. The stories that you can tell around the images make something very, very powerful.
This is going to change the world.
The folks at home, this is a huge deal.
Touchdown for science!
Hubble was fixed. Total success.
This is a small step for a capsule and a giant leap for science.
We might not actually even know what we're going to see, and that's part of the excitement.
After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.
It's the great American comeback story.
If you're looking to catch the April 8th total solar eclipse, you'll want to be somewhere with clear skies.
For some scientists, that means heading above the clouds.
During the 2024 solar eclipse, the WB-57 airplanes will be flying at an altitude of about 50,000 feet, chasing the eclipse shadow over the coast of Mexico near Mazatlan.
3 science teams will be using 2 WB-57 jet planes to study different aspects of the eclipse. Firstly, these 2 teams with instruments in the nose and wings will be looking at the sun's outer atmosphere, known as the corona. Scientists often study the corona using spacecraft with coronagraphs. These are occulting disks that help block out the bright sun, but they also cover up the inner part of the corona. During a total solar eclipse, the moon perfectly blocks the sun's bright disk, allowing the entire corona to appear.
A total eclipse gives us the best view of the corona we can get, and it's even better when viewed from above.
The most exciting part of using the W57 is to get over the clouds and to get to a layer of the atmosphere where it's so much less dense.
This means that you can access wavelengths of light that you normally wouldn't be able to access on the ground.
The team led by the University of Hawaii will measure different wavelengths of light using spectrometers and cameras.
Their instruments will give insight into the corona's chemical composition and temperature.
We want to figure out what kind of processes are operating in the sun just above its surface or at its surface.
For the team led by the Southwest Research Institute,
this will be their second time chasing an eclipse, so they're using an improved camera setup.
In 2024, we're flying an evolution of the experiment we flew in 2017. Back then, we flew 2 cameras in 2 different wavelength ranges. For this experiment, we're flying 4 cameras that can measure in 7 different wavelength ranges, and that gives us more information about the kinds of structures that we're going to see.
The corona could hold clues to what creates solar wind, the stream of charged particles coming from the sun that can cause auroras, but also potential threats to our satellites and astronauts. The sun can also affect technology closer to home, and the eclipse allows scientists to analyze those changes.
Beneath the plane, the team led by Virginia Tech will mount an instrument called an ionosonde to study how the moon's shadow will affect Earth's upper atmosphere, known as the ionosphere.
This is an electrically charged region of the upper atmosphere where GPS signals and radio waves travel. So during the eclipse, when the moon casts a dark shadow on Earth, scientists will see how the lack of solar radiation changes the ionosphere.
Sometimes GPS systems can be adversely impacted because of certain perturbations or variations in the ionosphere. Using this experiment, we can characterize and understand how changes in the solar radiation can impact some of these technologies that we rely on in our daily lives.
Being in the air not only gives the teams a better vantage point, but it gives them a longer eclipse too.
One of the main advantages of flying the instrument on the plane is that you'll be able to track the totality over an extended interval of time.
The jets will launch from NASA's Johnson Space Center in Houston, Texas, and travel 460 miles per hour,
allowing them to briefly chase the moon's shadow as it sweeps across Mexico and Texas.
This means the instruments will observe the eclipse 25% longer than from the ground, giving these teams a unique chance to do science.
We might not actually even know what we're going to see, and that's part of the excitement, is opening brand new discovery space and learning new things about the sun.
Let's talk about fossils. Not the dinosaur remnants here on Earth, but the galactic kind. Scientists recently found one that's helping them understand galactic evolution. Just 13 million light years from here is a galaxy called NGC 4945. At its center is a supermassive black hole. It's surrounded by both a disk of gas emitting a lot of light and a bunch of dust blocking much of that light. The galaxy is also in a phase of evolution called starburst, where a lot of stars are being born near its center. Recently, using X-rays, ESA's XMM Newton telescope spotted a cloud of cold gas in NGC 4945. The gas expands light years beyond the central part of the galaxy and pokes out into intergalactic space. NASA's Chandra X-ray Observatory helps study it too by looking at individual bright sources of X-rays within that cloud. Scientists think that the area of cold gas is a fossil of an eruption from a black hole that happened about 5 million years ago. That eruption may have caused the galaxy's burst of star formation. Studying galactic change is hard because it happens over such long time scales. But by looking at lots of examples, scientists can piece together how galaxies like NGC 4945 and our Milky Way evolve.
To know Earth, we must know our oceans. Water is the lifeblood of our planet, integral to all of its dynamic systems. Oceans are crucial conveyor belts, distributing heat around the globe and impacting climate and weather. With eyes in the sky, NASA's unique perspective gives an unprecedented view of our blue marble home. But how well can a space agency really know our oceans? More than you might think.
The National Aeronautics and Space Administration presents the first DSAT collected data for 99 days.
Since 1960, weather satellites have given us the ability to observe and track a hurricane from the time of its birth.
For the first time, ocean currents can be mapped from space with sufficient accuracy to study their effects on global weather and climate.
The original idea behind SeaWIFS was to monitor the color of the ocean.
The project that we're involved in is called NAMES. Kind of started from space and worked its way down to the ocean.
SWOT will give us an unprecedented view of our planet's water system.
Liftoff of the Falcon 9 and PACE, helping keep pace with our ever-changing ocean and atmosphere.
Earth coming up. Wow, that's pretty.
We live on an ocean world, and to explore our oceans is to uncover our home.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55. After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astro Materials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.
You know what really annoys me? It's literally only because of my perspective that it is even called an eclipse. If I weren't here to see it, then it wouldn't even...
No, that's so true. It's really important to notice that, this is the best time to view the sun. I mean, there's really no other time that you can see my corona or outer atmosphere than during an eclipse. It's just a shame that a certain national satellite needs to take up so much of the rest of the view.
Hi, I'm Katie Mersman. I'm on Goddard's digital team, and I make a lot of videos for social media. That means, lately, a lot of videos that are vertical. A lot of the videos I make these days are for Instagram Reels or YouTube Shorts. Along with being in a vertical format, these videos also come with really short time constraints, something like 59 seconds for YouTube Shorts. Fortunately for me, I already talk really, really fast, so it's just a matter of how much information I can fit into. Some of these videos are sort of person forward, where I film myself or someone else, often just on my phone, sometimes with an Instagram green screen background. My setup at home is literally just my phone on a stand, talking into it, using the script on my computer as a light. But it works really well, and it lets me talk fast. It lets me try a million times, unlike right now where I'm having to say this with people watching me. Another fun thing about social-verse video, particularly these short-form vertical videos, is there's a lot of tolerance to get weird. For the total solar eclipse in April, I worked with the social media leads for NASA Sun, NASA Moon, and NASA Earth, trying to come up with an interesting way to communicate the science of the solar eclipse. We came up with the idea of having all three of them in inflatable costumes as the Sun, Moon, and Earth, dancing around each other, getting into fights, literally pushing each other around. And that's something that maybe wouldn't have made sense for a longer form, more serious video, but I could film that on my phone in the course of one day and put out 4 videos just like that. We never know what's gonna work or not, and I hate to admit that as a social media person with lots of metrics at my fingers, but the algorithm on these platforms is always changing, which means there's always an opportunity to try something new, and sometimes it works really well, sometimes it doesn't. Another fun thing about these vertical videos is that they're a little more informal, a little less polished, and sometimes we don't need to have the highest quality production.
Try refilming.
So this is a little like a little mirror that's aiming at you all the time, regardless which way you're looking at it. My name is Xiaoli Sang. I'm a LiDAR instrument scientist and also work on other laser instruments. The instrument is a laser retroreflector arrays. It's a small retroreflectors mounted on a shell, on aluminum shell, support shell. It retroreflects laser light back to where it came from. The purpose is to, number one, to have a fiducial marker, a precise fiducial marker on the lander so that we know exactly where that is on the lunar surface. It serves as a landmark for future missions if you want to go back and land it there. When you shine laser on it, it reflects right back at you. So it doesn't matter which way you're looking at it. And so that will help us to range from orbit to the lander as it passes overhead. Commercial lunar payload services, NASA and American companies work together.
We have a number of residents, particularly residents living near warehouse environments, that experience poor air quality on a daily basis.
And when you have a health condition or sensitive, you don't want that kind of pollution in your house.
The best solutions are data-driven. When people are given the right data, they will make the right decisions for my community and communities across Chicago and the region.
So NASA has this new initiative, and it's called Earth Science to Action. And part of what we're doing is we want to understand the sources of air pollution and how it gets transported in the atmosphere. And these stakeholders are able to make the air safer to breathe.
Ground level ozone, it physically burns your lungs. NO2 is a toxic gas. It is linked with pediatric asthma. PM2.5, the small particles you breathe in, they're small enough that they can go through your lungs into your bloodstream. TEMPO stands for Tropospheric Emissions Monitoring of Pollution. It will measure air pollution over North America every daylight hour. This is really going to be a game changer, helping us understand pollution at the neighborhood scale.
2, 1, ignition, engines full power, and lift off. Intelsat 40E, go Intelsat.
Today's a really exciting day for both NASA and NOAA. Today, the
TEMPO satellite started its first scans of North America, and we've got 3 aircraft in the air flying over Chicago. We've got dozens of instruments on the DC-8, getting the in situ levels of air pollutants and greenhouse gases, and then flying above us right now is the G3 and the G5 with remote sensing payload. That's a very exciting day, historic day. We've been waiting over a decade for the TEMPO instrument to start collecting data.
You know, you build a satellite, it takes years to build it, and you test it in the lab, but you never know if it's going to work. When you ship it across the country, you put it on a rocket, you launch it into space. And so yesterday we found out that TEMPO really is going to be able to measure air quality over North America. One of the exciting things about this Aroma Stacks field campaign is it's going to help us calibrate and validate the TEMPO satellite. So while we're flying both the remote sensing and the sensors that are measuring what's in the atmosphere down low, TEMPO is scanning overhead. And so we're going to use that data to help improve the precision and accuracy of the TEMPO satellite. We're on an airbase, Wright-Patterson Air Base in Dayton, Ohio. There's jets taking off and transports taking off, and we have hundreds of people here. We want to understand the sources of air pollution and how it gets transported in the atmosphere. And what's wonderful is we'll work with our partners at EPA and NOAA to help make sure that NASA and these stakeholders are able to make the air safer to breathe.
If there's one takeaway from this mission, what we want to learn is how can satellites help us address air quality issues. We have this new asset into space with TEMPO, and it'll be operating over the next few years. So this is a pathfinder for us to integrate these types of measurements into air quality decision making. So there's a lot of people that are doing research in the community, and as we partner up and put our assets together, we can actually do something bigger than any individual component could do alone.
Uranus is the 7th planet from the Sun and the 3rd largest planet in the solar system. It also may have the coldest interior, emitting far less heat than its counterparts Jupiter, Saturn, and Neptune. It is known as an ice giant because it contains more ices, including water, methane, and ammonia, than Jupiter or Saturn. And while NASA's learned a great deal about this planet over the last 3 decades, there's a lot more waiting to be discovered. Back in 1986, NASA's Voyager 2 spacecraft flew by Uranus, making it the first and only spacecraft to visit this distant planet. Previous observations showed that Uranus has a unique tilt of its axis, so it rotates almost on its side, causing its poles to actually face the Sun. No other planet in our solar system has this feature. In its quick sprint past Uranus, Voyager discovered 10 new moons orbiting the planet that had not been seen before. And in the decades since, even more have been found. During its encounter, Voyager also saw new faint rings and explored the complex magnetosphere. Voyager only briefly viewed the planet's 5 major moons: Ariel, Miranda, Titania, Oberon, and Umbriel. These moons have a wide variety of terrains and geological features, some of which indicate possible subsurface oceans. Small Miranda has chaotic terrain, with deep canyons and tall mountains, but is likely now frozen solid. Ariel appears to have the youngest surface, with few impact craters. While Titania has a very old surface, the lack of large craters and presence of a large canyon system may indicate ancient resurfacing. Oberon is also covered with craters and has valleys and large mountains. Umbriel's surface is the darkest of the Uranian moons, and it sports a strange polar ring. The origin of this ring is still a mystery, but scientists believe that it may have been formed by an icy impact. Since Voyager, ground-based telescopes and the Hubble Space Telescope have played the leading role in our understanding of Uranus. Since 1992, Hubble has watched the slowly changing Uranian seasons, including changes in its unusual pale blue color and polar hazes. Telescopes have also revealed that Uranus has a complex weather system with massive storms that can last for months or even years, with wind speeds over 500 miles per hour. The ongoing search for ocean worlds and life beyond Earth makes Uranus an exciting target for the James Webb Space Telescope and for future up-close exploration. New data will help scientists to understand the formation and evolution of Uranus, as well as its moons and rings, and provide clues as to whether liquid water may reside beneath their icy crusts. The fascinating properties of this planet, discovered in just the span of a few decades, reveal that unlocking mysteries here can help scientists learn even more about our solar system and our place in it.
When I began with the Sungrazer project, we had less than 1,000 comets. That was over 20 years ago. So the fact that we've finally reached this milestone, 5,000 comets, it's just unbelievable to me. Sungrazer project is a project that allows anyone, anywhere in the world to sit down with a laptop and discover comets. The clue to what a sun-grazing comet is kind of in the name there. It's literally a comet that grazes by the sun. The Sungrazer project relies exclusively on images of the sun from spacecraft, and the images that we discover nearly all of our comets in come from the Solar and Heliospheric Observatory, or SOHO. That is a satellite that was launched in 1995, so it's been operating for a long time now.
3, 2, 1, ignition, and liftoff of SOHO and the Atlas vehicle on an international mission of solar physics.
Our participants go to the SOHO website where we have all of our latest images from the spacecraft, and they download those images, and it's really as simple as looking through them, flicking through the image, and looking for something tiny and faint and moving in a different direction to the stars. Discovering a comet is a very unique feeling. You have this realization that suddenly you've found a piece of the solar system, a piece of the universe that no one has ever seen before. Prior to the launch of the SOHO mission and the Sungrazer project, there were only a couple of dozen sun-grazing comets on record. That's all we knew existed. The 5,000 comet milestone is a huge achievement. It's one that none of us dreamed we would even get to. So simply the statistics of 5,000 comets and looking at their orbits and trajectories through space is a super unique data set. It's a really valuable science, and it is just a testament to the countless hours the project participants have put into this. We absolutely would not, under any circumstance, be here if it wasn't for what our project volunteers have done. That's really what 5,000 comets represents. It's 20 or more years of invaluable discoveries from the project volunteers.
What color is the ocean? Trick question, it's all kinds of colors. Blues, greens, reds, yellows, and swirls of all of the above. And these colors can tell us a lot about what's going on just beneath the surface, what's thriving, or changing, or could pose a threat. For over 20 years, NASA has been looking at the color of the ocean with technology that's, well, over 20 years old. And that has told us a lot about the health of ocean ecosystems, but there are details we just can't see. Enter PACE, the Plankton Aerosol Cloud Ocean Ecosystem Mission. PACE's new instruments will look at our world's oceans, lakes, and rivers in an entire rainbow's worth of color and beyond, giving us new insights into marine communities, the carbon cycle, and climate studies. So let's take a look at the top 5 official best ever ocean colors of all time. This is the open ocean. Here, the oceans absorb the longer red wavelengths and scatters the blues. In these vast stretches of deepest blues is where the tiniest of bacteria cycle and recycle nutrients in microbial loops. For example, the tiniest and most abundant photosynthetic organism, Prochlorococcus, converts carbon dioxide into organic compounds and forms the base of the marine food web. These phytoplankton are eaten by tiny zooplankton, and then eaten by larger zooplankton, then smaller fish, and so on. And then return the nutrients back through respiration and remineralization, which are then taken up by the tiny microbes. But here is where things are changing. These deep blues are getting greener with a warming climate, but exactly how and why is unclear. Despite some scientific theories, the past and present satellite sensors just don't have enough sensitivity to color to tease that out. PACE will fill in those gaps with higher spectral information and slowly, over time, be able to discern the drivers associated with these detected changes. This appealing brownish orange is the result of what's known as colored dissolved organic matter. We can think of it as a kind of tea that leaches out of dead or dying organic matter, like the tannins from broken down leaves, giving the surrounding water a darker, browner hue. Found in higher concentrations in lakes, rivers, estuaries, and marshes, colored dissolved organic matter is a great proxy for dissolved organic carbon, a big pool of carbon in aquatic systems, and it's an indicator of the health of an ecosystem. Much like a cloudy cup of tea, higher levels of this organic matter don't let as much light through, changing the availability of light for plant-like organisms in the environment. With PACE's ocean color instruments' hyperspectral measurements, even into the ultraviolet wavelengths, we'll be able to differentiate sources of this organic matter and better understand the transfer of carbon across land and into coastal regions. A grayish-green in a large lake like this could spell potential harm from a bloom of blue-green algae known as cyanobacteria. Depending on the type and abundance, cyanobacteria can spread toxins to aquatic and human life. In 2019, Lake Erie saw a bloom of the Microcystis cyanobacteria form a thick layer of scum filled with a toxin, which posed a major risk to drinkable water. The microcystin toxin can cause liver damage, dizziness, numbness, and vomiting. Researchers are eager to use the hyperspectral information from PACE in order to detect early stages of harmful algal blooms like the ones in Lake Erie. PACE will be able to measure the unique optical properties of cyanobacteria, which will help separate the harmful algae from other phytoplankton present in the water and allow resource managers to monitor the health of fresh water. This turquoise stretch tells us a lot about the sediment churning in the water, and both the quality and quantity of that sediment can have big impacts on marine life. For example, in Greenland, glaciers can bulldoze over surface rocks, grinding them into a fine powder of silt and clay known as glacial flour. The glacial flour changes the appearance of the water, with the particles absorbing the shorter wavelengths, purples and indigos, and the water absorbing the longer wavelengths, the reds and oranges. This sediment can bring nutrients and fuel algal blooms. But if you're an oyster, sediments could be a big problem. When lots of sediment is suspended in the water, filter feeders like oysters can't feed as efficiently. And high sediment levels can be associated with increased harmful Vibrio bacteria, which can cause sickness and even death when those oysters are eaten. PACE's hyperspectral measurements will see far more variability in reflectance and give us better estimates of water clarity and particle size. And that data could be used by oyster farmers monitoring the health of the shellfish population. As the days grow longer in the subpolar regions, a milky, swirly light blue hue grows in the oceans. This is the telltale mark of coccolithophores. Coccolithophores? A kind of phytoplankton that is completely covered in a chalky shell of calcium carbonate. When these plankton bloom and then die off, that inorganic chalky material sinks to the ocean floor. PACE will better observe these particular blooms, allowing researchers to account for the amount of carbon coccolithophores remove from the atmosphere and sink into the depths of the ocean. If all of these colors can tell us what's going on with our ecosystems, our health, our climate, then PACE's enhanced resolution is going to reveal new levels of detail in how humans and water are connected in a changing world.
for complete newbies, how does a hot air balloon work?
It's a great question. It's physics, simply. We heat up the air inside the balloon, and that makes it less dense, and then that makes it float. Now, what that means, though, is we can only control up and down. The way we fly and the way we navigate is by choosing different layers of air to fly in.
And I've heard that there is a box, the Albuquerque box. Could you explain what that means?
Certainly, it's one of the reasons why Albuquerque is a famous place for ballooning. Sometimes what happens is at a higher elevation, the wind is going to the north, and at the surface, it's going to the south. That's what we call the Albuquerque box. Sometimes the box works out such that you can fly to the south and go up, fly to the north, and then come down and fly back south and land right where you took off, which is an extraordinary and wonderful accomplishment. It's super fun when you can do that.
So for someone who's never been in a balloon, what is it like?
It's unlike any other form of flying. In a balloon, you're actually outside, right? You're standing in a little basket, and there's no windows. You're just out there in the air. And it's just science, right? It's buoyancy, like I said, it's applied physics, but it feels like magic. It's a ballooner eclipse.
Oh yeah!
I love that. It's very calm. There's no movement, no wind. When you're moving with the wind, so you're at equilibrium. It feels very calm and peaceful. At the same time, it's really exciting and it's intense. So it's this wonderful combination of intensity and mellow, serene, tranquil beauty, absorbing nature. You can never experience that in any other form of flight.
Conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics.
And that we should be able to fix it in our insurance program.
Thousands and thousands of people worked on Hubble. And by the way, if you ask all of those thousands and thousands of people before the launch in April 1990, what's your 10 biggest concerns about what could go wrong on Hubble? I absolutely guarantee you that not one of them would have said spherical aberration or a bad mirror.
And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
Spherical aberration is a problem in the surface structure of the mirror. The mirror is supposed to be ground to a perfect parabola where all parallel light coming down comes to one focus. Spherical aberration is when one part of the mirror is slightly higher or lower than the other, and light, instead of coming to one focus from, say, the edge of the mirror, will come over here, and then from the center of the mirror will come to focus up here. So you get, what that does is blur the focus.
You can almost think of it, if you've got bad myopia, which you can say our telescope has now, and you put your glasses on, you can correct totally and get 20/20 vision.
I'll never forget the day of the fabled press conference at Goddard when we had announced to the world that the Hubble was broken and we didn't know if we could fix it. We didn't frankly think we could fix it. Except just before the press conference, Space Telescope Science Working Group, a bunch of about 20 astronomers involved with Hubble, were meeting at Goddard coincidentally that day. And I ran into John Trowbridge. He was a scientist on the Wide Field Camera 1 team, the one that was taking all the fuzzy pictures. And he called me over to the hallway and said, "Ed, I want to tell you something." I said, "What?" "We can fix this." I said, "Come on, John, what do you mean?" He said, "Now that we know the prescription of the mirror, the shape is perfect, but it's got the wrong shape, just like your nearsighted eye. Now that we know the exact prescription to 5 or 10 decimal points, there are 4 little mirrors inside our new camera that we're building, our backup camera called the clone, the WIFPIC 2 clone. There are 4 little called relay mirrors. If we reground those with the correction that we know we need in it, like glasses for your eyes, we could solve the problem internally right away, 1993, when we go up to fix it." I said, "Are you sure, John? Because I'm going to tell the press this." He said, "I'm positive." So during my press conference, I gave all the nasty things. We're not going to be able to take any pictures. We're not going to be able to do this. However,
we feel that we can characterize the problem, the spherical aberration problem, well enough that we can take advantage of an insurance policy that we haven't talked much about, and it hasn't been in the press much, and that is we started a long time ago to plan a maintenance program. That is, every 3 years we plan to go up with the space shuttle, change out instruments, change out things that broke.
Before launch, if you had said what would be success, I would say 50% and the whiff pick. But the whiff pick had to be. CoStar by itself, I don't think would have made the difference, but whiff pick, images. People aren't going to believe a spectra. Think about it. Would people believe a nice, beautiful spectrum fixed the Hubble Space Telescope, or a picture of the Eagle Nebula? I leave it to the audience. So that's what I said. Whiff pick and about 50% of the other things, and would be happy because we'd never done this before. This is the first time NASA ever tried 5 EVAs, more than 6 hours each, and to do all these different things. Whiff pick, CoStar, gyros, solar panel. I mean, we were doing everything except putting in a new kitchen sink. So we all fly to Houston. The first EVA started. Of course, all these things happen at night, but astronomers are used to the night. Every night it became like a dream sequence. Because every night they'd start, they'd get this done, that done, whiff pick went in. Next night they got CoStar in. Next night they got gyros in. By the end of the 5th night, we're looking at each other like, are we dreaming or did this happen? Did we just do 5 successful EVAs and fix everything? So we came back from Houston like on top of the world. But it was like, it was like you had major eye surgery and the operation was a success, but you still had the bandages on. And we had to take the bandages off sometime. We're all looking at this monitor when the picture was taken, and it was just a real rich star field. And what we're hoping not to see is a bunch of fuzzy stars with all kinds of weird rays coming out of them, like they used to be in spherical aberration. So the image started coming up, and this is an old cathode ray tube, so it's, I know this is technology that some of the young people in the audience don't know what I'm talking about, but it took a while for the image to build up. And we first saw a little bright star in the center, and then some fainter stars came up. More and more stars came up, but you could hear a pin drop. You could have heard an atom drop on the floor. It was so quiet. And slowly, more and more stars came up, and they were sharp. And there were lots of them, because when you're out of focus, you don't see very faint things. When you're in focus, you really see deep. And then the picture was there, and it was perfect, absolutely perfect. And there was still a moment of silence, and then everybody just went crazy.
Hey! Right there! Oh! Get it! Wait. Oh, no. Yeah, let's get it. Bring it up. Yeah, bring it up. Bring it up. Come on. Oh. Come on. Not bad. That's it. There you go.
And I can't describe it. Everybody was just hugging each other, crying, tears, Somebody came in with champagne, it was just a moment I'll never forget as long as I live. Hubble was fixed. Total success. You couldn't have had a bigger success in that first servicing mission. When Hubble was launched, I always thought that it would die about, and I'd have another 10 or 20 years in my career. And here I retired 10 years and it's still going. Yeah. It made me the butt of jokes. It made me a collector of arrows, slings and arrows from my neighbors. The press thought I was a joke. And seeing where Hubble is now, making those early promises look like nothing. I mean, a piece of cake. I mean, it's iconic. It's the greatest American scientific achievement ever. It's the great American comeback story.
We should be able to fix it in our insurance program. I think we're all committed. Nobody's walking away. I think we're all committed to work on it and do it right.
Inspired by everything I learned about at Goddard. Earth science, space science, astrophysics, geology, everything cool about the universe feels like it was happening at Goddard. Not even in my own group. I reached out, I worked on other missions studying gamma rays, missions studying all kinds of things, cosmic rays. It was awesome for me. And really, it was my dream job. Just watching something that I made go to space was just a complete and total dream come true at the time. It's hard to believe that now I'm actually going to be going into deep space myself.
We've come a long way in weather forecasting since the early balloon launching days, thanks mainly to weather satellites. Just 15 years ago this month, NASA launched the first Tyros weather satellite from Cape Canaveral. The views of Earth were pretty rudimentary compared to today's high-quality pictures, but they proved that routine global weather observation by satellite was possible. With each succeeding one, these weather sentinels have become more and more sophisticated.
For me, storytelling has always been the way to reach the heart. The stories that you can tell around the images, along with the images, make something very, very powerful.
Science and technologies, especially satellite imagery, are absolutely essential because people's livelihoods, natural resources, and biodiversity are connected to each other. Satellite imagery are our eyes in the sky, providing those insights and up-to-date information.
Sasa tunawasikilizeni nyinyi ndio wenye misitu. Wote mnaridhia? Bila mashaka. Kizenga oye!
Going around the villages at the beginning of our Tukari program, helping the villagers understand the importance of conservation and what the deforestation was actually doing to harm them. I will never forget when Lillian and I went to one of these villages and he'd acquired one of these huge satellite imagery maps and we laid it out. The villagers were sitting around it and their excitement was absolutely fantastic. And there was one woman saying, "That's the tree where I put my baby when I'm working in the fields." And another man was saying, "No, we can see our sacred sites, this tree and this rock." And I remember one woman, and she said, well, I used to do my farming on this hillside, and she pointed to it. And she said, but then all the trees went away, and there was this terrible landslide which showed on the map you could see where the mud had slid down and there was no vegetation left on either side. So she said, now I understand. Now I know that it's worth walking a whole extra hour in the morning to get to a place where I can cultivate the land without causing this terrible destruction of the environment.
Takale gives me hope. The way it gives me hope is it is changing lives. And it is also empowering the local voices. You find there are people, they call themselves like forest guardians, friends of forest. There are people who are becoming, tree planting groups.
More than 80% of biodiversity are in the hands of indigenous people and local communities across the world. In Africa, on average, more than 65% land tenure is in the hands of local communities. So if we want to achieve conservation impact and address the climate change, we have to work with local communities and not only engage them, but empowers them to own and drive decision-making in their landscapes.
Well, the CORI approach began when I flew over the Gombe area. I flew over an area which in 1960 was part of the equatorial forest belt that stretched right across equatorial Africa to the west coast. By the late 80s, I flew over in a small plane and I looked down and I saw a tiny island of forest. Gombe National Park is very small, surrounded by bare hills. As you know, I spent many, many years studying chimpanzees. When I began, there was probably between 1 and 2, and I'd say closer to 2 million. And today, 100,000 to 300 and a bit thousand is all that's left. Many of them are in fragmented environments, isolated genetically, and have little chance of survival. So they are highly endangered. And if we don't take action, then they will become extinct.
The NASA satellite data helped us understand what does it mean to be a chimp. It helped us understand where to protect them. NASA supports, launches, and maintains and manages constellation of different satellites, and some of them going all the way back to 1972. By providing this data to the conservation community, it helps us continuously monitor the chimpanzee habitats. The chimpanzee habitat suitability model, developed with support from NASA and University of Maryland, includes more than a dozen variables directly extracted from Landsat satellite imagery. It includes NDVI, it includes percent tree canopy cover, it includes tree heights. Using conservation standards approach and dashboards, we take these models and turn them into habitat health indicators, into actionable information people on the ground can actually work with. And the conditions of the forest can change quite rapidly due to illegal logging, mining, or any other threats. So this information is updated in near real time, so that conservation decision makers can see the individual threats affecting chimpanzee habitats from village to national scales and across the entire chimpanzee range in Africa. And this NASA data helps identify areas under threat of illegal logging or fire damage where local managers could be deployed to mitigate the threat. In addition, mobile apps enable community members to become involved in not just tracking changes in the habitat, but to be active in enforcing the protection of the village forest reserves from degradation. Community leaders have even used this data to inform their village land use planning, voluntarily moving farms away from areas where forest restoration would lead to the greatest gain for watersheds and people.
It works both ways. Sometimes you show a lush forest And then you show how a few years later it's devastated. There's just a few burnt stumps. But on the other hand, there are other images which show you a devastated landscape, and then 5 years later, trees coming back, regeneration, new hope, new life. So the stories that you can tell around the images, along with the images, make something very, very powerful. And you need both to make the kind of impact that we need to make today to help people understand the devastation we've caused, but to give them hope that we can turn things around. And that's what these satellite images show so clearly.
I'm convinced that we have planted a seed that is going to spread, and this is the very good way of trying to ensure our contribution to the mother planet.
My future is a future where technology is married to compassion and love.